Am I audible to everyone? Can anyone respond, please?
Yes, audible, please.
Yeah, okay. Thank you. The slides are moving. Uh, can you see?
Yeah, first slide is visible.
Okay, okay, wait. Okay, so this is for the live session of introduction to biomass conversion and biorefinery. So I am Smita Mondal. I am PhD scholar in IIT Madras, and I am doing this NPTEL TA as a part of my PMRF TA duty. So today we will be discussing mostly as a introductory part of the biomass conversion and biorefinery. So as an introduction, which, yeah. So as we know that we use lot of fossil fuels for our daily needs, energy consumption, and other lot of chemicals are produced by the fossil fuels. Utilizing, we are exploring our resources. Those are being evolved over the few years, like millions of years, to produce that much of reservoirs for fossil fuels. So obviously those are very high density fuels, very energy density fuels, but we all know that it has a very adverse effect on the environmental pollution. So the focus on being mostly has been discussed in the introductory part, that is how the energy consumption is introduced, like based upon the biomass based fuels, and what is the current status of the fossil fuels. Now I would like to say that fossil fuels we can't replace overnight. Now we are in the evolution part of biomass to take into account the energy produced by the biomass sources, because those will be a sustainable way, and a lot of reduction of carbon footprint in the environment, right? So uh, moving onwards, the global warming, which is driven by the excess release of the greenhouse gases, mostly if I want to consider the CO2. Lot of researches are going on the CO2 reduction or the CO2 conversion. Now this greenhouse gas, other greenhouse gases are methane, that is mostly more like more potentially harm, it does harm to the environment than CO2, but mostly we are considering CO2 as a greenhouse gas emission, which is being emit from the fossil fuel burning or fossil fuel consumption. Now this becomes a very dangerous and very threat, environmental risks for the society, as well as human being as well as other animals. So the energy sectors which majorly contribute the greenhouse emissions they demand the urgent transition towards a sustainable and eco-friendly alternative. Now, eco-friendly alternative, those as well as they can meet our urgent, they can meet our requirement of the daily basis, as well as they will uh, make the path, like make the carbon emission very less, or negative or zero carbon emission. That is our target in the 2050, up to till 2050. Now, the biomass conversion or biorefinery, this technology, they offer the promising pathway to mitigate the environmental impacts of conventional energy sources while addressing also the global growing energy demand. How these processes are being done, like what are the processing of biomass, how the biomass is converted into solid, liquid and gaseous fuels, those will be detailed discussion in the upcoming classes. Now I am giving you the very introductory part. Next is the biomass, which is derived from the mostly, the organic materials. Those consist of agricultural residues, forestry waste, and energy crops. Few like energy crops are there, which intentionally it can be used as a huge production by agricultural method, and we can use it as a source of renewable energy. Now this gives a very range of like valuable products, including biofuels, biochemicals and bioenergy. Now, coming to the biorefinery, it is like almost you consider it like a petroleum refinery, which is integrated with various technology which can convert your biomass into diverse end products. Okay, diverse end product. Sometimes this end product doesn't even contain carbon. Some other valuable end product we can also get from the biomass conversion method, and those are sustainable and also efficient in a efficient way. So this approach, this biorefinery or the biomass conversion approach, not only reduce the dependency of the fossil fuels, but also it offers several co-benefits. Like we can do the carbon sequestration. See, there are a lot of researches which are going on, like CO2 sequestration under the sea or under the seabed. So those are sequestered in the form of gas hydrate. That is a very interesting topic of research as of now, and there is very less in like large scale application is still it not being done. But we know that there are a lot of gas hydrate, like methane gas hydrate, those are already existing in the nature in the form of, like we can also see this is carbon sequestration, those are methane sequestration in the form of gas hydrate. So researches are going on the carbon sequestration part as a part of hydrate. But when we are considering this biomass approach or this like a very clean approach, so we can say that our trees or the biomasses, those can also sequester the carbon in a natural way, and also it benefits like various waste management we can do, and also the economic development in the rural side as well. By utilizing the locally available feedstock, we can do the biorefineries, minimize the carbon footprint which is associated with energy production and transportation. But this footprint is still, it requires lot of researches, because when you consider the biomass processing before introducing to the biorefinery, it takes lot of energy. So that energy should not come from fossil fuel burning. If it is so, then there is less valuable input in the reduction of carbon footprint efforts, right? So when we want to minimize the carbon footprint, it should be noted that the energy, whatever we are using for the biomass processing or biomass conversion, that energy should also be sourced from the renewable sources like solar energy or wind energy, like that. The use of these advanced technologies such as pyrolysis, gasification, these are thermal conversion method, and also as well as enzymatic or the biochemical methods, those are very efficient and they can enhance the overall process efficiency and environmental performances of the biomass conversion process. So, as the world it progressed towards the achieving net zero carbon emission by 2050, biomass conversion and biorefinery this system this represents a very critical component for the energy transition that the industry wants. They want to reduce the carbon emission, but they also want to do this energy mixing or the huge transition in the energy consumption. So their adoption of this technology can significantly contribute these greenhouse gas emissions, supporting their circular economy principle and and fostering a sustainable future for the coming generation. Now, moving onwards, I will discuss now that what are the world energy scenario. So, in order to avoid or prevent the worst impacts of the climate change, the emissions, various gas emissions, mostly the emissions here introduce the CO2 emission, needs to be reduced by 45% by 2030. It can and reach almost net zero CO2 emission by 2050. The target is to limit the global temperature rise below 1.5 degrees Celsius above the pre-industrial level as per the Paris Agreement. Now, to meet the target, the world's energy transition is transforming rapidly. Everyone is doing lot of researches, trying to take lot of technologies into the market to reach this energy transition in a rapid way, or to make the process faster. But as I already said that fossil fuel complete replacement is not gonna possible overnight. So in that context, the demand for the renewable energy continues to grow as it is expected to become the dominant source of new power generation capacity by 2030. However, this clean energy progress is still far slow to put the global emission into the sustained declining net zero achievement by 2050. The obviously when I will discuss the lot of challenges that we are facing while processing the biomass or um, running the biorefinery, there we face lot of challenges when we compare with the fossil fuel handling and the biomass handling, or fossil fuel conversion and the biomass conversion. The overall challenges when we compare, then we can see that the progress using this biomass conversion or biomass processing, it will take lot of time to get that much of scale up or energy efficient in the large scale process. In 2023, when we saw that 560 gigawatts of renewable capacity was added globally, marking a significant leap towards the reducing of the reliance of fossil fuels. Now there is one concept, that is the power mixing concept. Now the global power mixing transformation, it is an effective and unique strategy to reduce the consumption of the fossil fuels. Now when you see this graph, this is the global CO2 emission scenarios reporting from 2000 to 2050. So these are some like places they have taken, but see, this is still some gap. Now this scale, it represents the CO2 emission. Okay, Now, this is the year you can see, like 2050, we need to achieve the net zero, right? But there is still some ambition gap. This much of work we have to do, so that this actual CO2 emission, it can come down to net zero condition. This is the pre-Paris Agreement baseline. When we take this baseline, there is huge evolvement we want to do. We have to do to reach this net zero CO2 emission by 2050. Now, when coming to the clean energy technology, so clean energy technology, it consists of wind energy, solar energy, nuclear, and other hydrogen as a clean source, and also the other CCUS. This you can see that uh, as a part of this, um, the mostly is accounted by this solar PV. Lot of solar PV is installed as a part of this renewable energy utilization. And when it comes to 2035 to 2050, we can see the largest contribution, it comes from the other source, which includes the energy efficiency improvements, other fuel sources such as electrification or switch of biomass or behavioral changes. So it includes the lot of biomass conversion method of electricity production. So this is the scenario of global energy mix to 2050. So we can see that clean energy is expected to grow over 2050. Um, when there is a trend of declining trend of coal consumption, okay, and also there are chances, like these are the stated policy scenario step, and this is the announced pledges scenario. So but net zero emission, we can see that 2050 it is around clean energy contributes most in the all of the cases, right? So we are towards, slowly we are moving towards the clean energy that mostly encounter the energy that is produced from the biomass. Now, coming to the world energy consumption scenario, according to the World Energy Statistics 2023, the global primary energy consumption has reached a record absolutely high, up to 2% on the previous year to 620 exajoule. In association, emissions, CO2 emissions from energy, it increased by 2%, exiting almost 40 gigaton of CO2. So when we see the figure, this is the global primary energy consumption data from 1990 to 23. We can see that mostly is contributed by the fossil fuels, right? Mostly the uh, energy consumption is done by using the fossil fuel burning or fossil fuel utilization. So the fossil fuel reliance is not something that we can easily, it is not be replaced seriously, but this approach of slowly moving that renewable, it comes to the picture now for the energy production. The other forms like hydro energy or nuclear energy, those are also coming into place by years. So still we can see over the data up to 2022, the mostly energy consumption is still is happening using the fossil fuels. Now, when we see the per capita primary energy consumption, which is this data is taken at 2023, so we can see that mostly this coal and oil and gas, natural gas, these are hugely consumed for the energy consumption. But you can see in the Sweden, there the other renewable side is still being considered mostly in the energy generation, but in if the overview, you can consider that all of the cases in all of the country, we are using mostly the fossil fuels for huge amount of energy supply over the country. So this is energy consumption scenario coming to our country, India. Sorry. Yeah. So this is source is the primary energy supply. So as per 2023, here itself we can see that we cannot replace the fossil fuel, right? As of now, there see lot of contribution is for oil and coal for energy consumption, also the natural gas, this part, and the renewables, they contribute very less. See, as a data, renewables consider only 0.88 percentage, while mostly the oil and coal are contributing for the primary energy supply, also the gas, natural gas. Sector wise, there is data that represents that mostly in the industry and the commercial applications, also commercial applications and the residential application, the lot of energy is consumed. So these are the primary resources, primary point of CO2 emission, point sources we can consider. Now there are also CO2 emission due to this energy. See, the in energy is also consumed like for the transportation, but you can see that the residential, the industrial part, and the this commercial application, these are some huge energy consumption area, right? So these are the main you can say main point of CO2 emission. CO2, lot of CO2 emission is happening from this kind of application where the lot of energy is being consumed. So now we are discussing of energy mixing scenario, that why energy mix is being a new strategy to meet the energy demand of the country. It is being a new strategy. So globally, we get the largest amount of our energy from, obviously I have discussed the oil, followed by coal, gas, natural gas, and some hydroelectric power. However, other renewable sources are now growing very quickly. We are a lot of introducing the solar source, the hydro source, and other renewable sources. Biomass is still, it is taking time to grow as much as fast as this already existing technology for the oil, coal, and natural gas processes. So energy production mainly, which is we are using the burning of fossil fuels, accounts for three-quarter of the global greenhouse gas emission. Lot of emission is happening for the burning of fossil fuels. The world therefore needs to shift away from the fossil fuels to the energy mix condition or the energy mix strategy, which is dominated by the low carbon source of energy, renewable technologies, and the nuclear power. Today, when we think about the energy mix, we think about the diverse range of the sources. Right? We can mix with these are the sources, right? Coal, oil, gas, nuclear, hydropower, wind, solar, biofuels. We can mix as a percentage of like that, so that we can when it is required as per the requirement, we can mix the these energy sources, and we can meet the energy demand with a low carbon emission condition. The term energy mix, which refers to the combination of various sources used to meet the energy needs in a given geographic region. Now it includes the fossil fuel as well as nuclear energy, also the renewable energy. That is, renewable energy considered also the geothermal. I forgot to mention it also considered geothermal, but it is mainly geographical way, like all of the places we can't access the geothermal energy, but where it is we by the geographic condition where it is accessible geothermal energy, we should totally take the advantage of using the geothermal energy to useful energy as a like daily energy consumption pattern. So, fossil fuels that remains the greatest source of electricity generation. It is happening worldwide. We also have seen the graph that all of the country, the fossil fuels are the main source of electricity generation. Now in 2023, coal accounted roughly 35.5% of global power mix, while the natural gas followed by 23% share. The share of the renewable in the global electricity generation has been seen more pronounced over the recent years, when lot of researches are going on. So gradually, the energy production from the renewables are also taking into picture. Following, also there are lot of efforts by the government to combat the global warming and decreasing the levelized cost. So, a projected electricity generation worldwide in 2022 with a forecast of 2050. Now, this graph look like this. Now, in this graph, we can see that the contribution of the renewables, that is hydro, including the hydroelectricity, it is growing. The curve, this blue shade curve, is growing on, and the contribution of the coal, it is we are keeping almost in the same level. It is static consumption, while the natural gas is also we are making it as a constant level. Nuclear is somewhat increasing, but the liquid fuel, we are liquid fuel, I guess, produced from the coal, it is currently we are eliminating this. As in the graph we can see there is no green line, right? So the mostly focus is being we have focused has been given to this renewable source of power or electricity generation by the end of 2050. So is there any question till now? So I will move now mostly the renewable energy portion, that is biomass concerned. I have just discussed about the world energy mix scenario, or the world energy consumption scenario as per the recent data. Now I will move forward with the renewable energy, that is focused on the biomass, and also I will discuss the biorefinery concept. Okay. So let's now start with the biomass concept. Like biomass is a renewable energy source which is derived from the organic materials. Now it is this energy is considered to be carbon neutral because it releases the amount of carbon that the plant itself has the capacity to absorb during their growth, right? and also they absorb the absorb the carbon dioxide for their photosynthesis. Now, what are the forms of biomass that we consider for the not only energy generation but also some valuable product generation? Wood, those are extensively used for the heating purpose in the form of sawdust or chips or pellets. Also, those from the wood also we can extract lot of valuable chemicals in the industrial processing. uh, Various kinds of crops, energy crops or residues, those are agricultural byproducts, just like corn stalks or straw or some kind of soybean or wheat. These are various crops, those are highly efficient for the biofuel production. Lot of researches has been done for generating biofuel using using those kind of soybean, corn, this kind of sources, biomass sources. Those are also used for generating heat and electricity. Now, considering this municipal solid waste, so municipal solid waste itself a huge mixture of biomass, as well as there are other compounds are also present. Those are not biomass based or biomass sourced, right? So municipal solid waste, if we can efficiently utilize this solid waste into the biomass refinery to make valuable product out of that, it is a great benefit for the society, so that this not only reduce the carbon footprint, but also it helps to keep our environment in a clean, or our work very easier to manage the solid waste management in a city or in our household conditions, right? So animal waste, this is also an huge source of uh, various kind of valuable product, uh, valuable product we can convert from the this kind of waste. So those are mainly converted into biogas by anaerobic digestion, which can be used for heating or energy as a purpose. Algae, those are obviously those are cultured in a controlled environment, or cultured, or those are naturally it grows in a controlled environment, but these are very highly efficient for the biodiesel production. Now, the biodiesel production also becomes very important nowadays, because we can mix the fossil fuel diesel with some percentage of the biodiesel to reduce the carbon footprint, right? So biodiesel production is of great interest in the research level as well, to just like how what are the sources, what are the biomass sources we can use to produce a more efficient way, more high density biodiesel. Now, the energy crop, those are specific kind of crops, like just like switchgrass, or these kind of energy crops are cultivated explicitly for the energy production purpose, and providing biomass also for heat power generation, as well as the liquid biofuels we can get from these crops. Aquatic plants like duckweed or some plants, those grows under the water, under the water environment, those are often cultivated in the aquatic environment, and those are used for generate electricity. So these concepts, like usually 10 20 30 years back, we didn't even imagine that how much it this biomass, that in the rural area we usually use the wood and those kind of biomass sources for the energy purpose, energy production, right, heating or cooking purpose. But the when after years, when the research or the technologies are evolved so much, that we are now able to think that how the biomass even we can utilize in a way that we can produce lot of valuable chemicals, those can be sold in the market in a very high price, not high price, in a very valuable product condition. So and also in another way, those are sustainable process, and making the environment less harmful by introducing more CO2. It is not introducing more CO2 even when when we are doing agriculture of this kind of energy crops, or intentionally we are doing agriculture to produce at the end mostly the valuable chemicals out of the biomass. So we are, once we are making the carbon cycle as a closed, because we are doing agriculture, or the we are helping, we are growing the biomass, those are capturing the CO2 and emitting the CO2. So at after emitting a CO2 in the stage of conversion, biomass conversion, there we can say that some part of the CO2 is being emitted because of the electricity consumption and other parts. But in a overall process, we can make the carbon cycle as a complete cycle, neutral cycle, by utilizing these biomass sources. There are a lot of biomass sources are there, so those are used, processed, and converted into valuable products. Now, what are the advantages that we want to refer over the fossil fuels as a renewable energy? So, this biomass offers several benefits over the traditional fossil fuels. So, first part is the renewability. Renewability, it is derived from the organic material, and also it can be replenished over the time. Carbon neutrality, it is maintained, like carbon dioxide is released during the biomass conversion, where it is offset by the carbon absorbed during the plant growth. Waste reduction, biomass utilization helps to reduce the landfill waste by converting the organic materials such as sawdust or agricultural residues, also the MSW, into valuable fuels. Biomass can also be locally accessed. We don't have to wait for the other country to import our biomass, right? Just like sometimes oil import, it invests lot of economy around the oil import scenario. So for this case, when we are considering energy source as biomass, those are local sources. Okay, so reducing the transportation cost as well, and also the supporting the local economy. Energy security also, by reducing the reliance on the imported fossil fuels, biomass contributes to greater energy security. Energy security long term, it is because we are getting in a locally sourcing way, biomass production is happening, so it gives more security because it is a sustainable way. It is nothing like fossil fuel is in the process of depletion, right? The consumption, it is depleting, it should deplete because the source is depleting. So in that aspect, biomass is never ending process, so we are producing lot of biomass every day itself, and there are a lot of different kinds of plants are there that we can cultivate over the as a energy crops to sustain this process. Now, cost effective, although the initial investment for the biomass system can be high, but ongoing production and sourcing cost often lower than the fossil fuels. Also, the ecosystem services that biomass production can contribute to environmental benefits such as soil conservation and as well as biodiversity. Agricultural residue can also prevent the soil erosion and nutrient loss. So there are a lot of combined benefit when we are using the biomass as a huge production, huge cultivation, and also as a source of the energy production. So we are getting multiplied benefits out of that. So, coming to the biomass energy in India, biomass energy, which becomes a significant component in the Indian renewable energy source, um, accounting for almost 32% of the nation's total energy consumption. As the second largest producer of the agricultural residue globally, India has set the ambitious target for renewable energy, including biomass. The country aims to achieve 175 gigawatt of renewable energy capacity by 2022, and with biomass expected to contribute around 10 gigawatt. So now the value has been increased, but I have reported up to 2022. India's biomass resources are highly diverse in characteristics, ranging from agricultural residues to forestry residue to in the urban and rural areas, as well as animal wastes. These sources are crucial for reducing the dependence on the fossil fuels, addressing the climate change. Now the agricultural residues is contribute almost 65% of the India's total biomass based energy resources. The Ministry of New and Renewable Energy estimates that India could generate up to 18,000 megawatt of power from the agricultural residue only. मतलब, based on the agricultural residue itself. Key sources include rice straw, wheat straw, and the sugarcane base. This sugarcane industry, it is a like sugarcane baggages. These are huge, highly used for the power generation. Also, this kind of straws, right? After extracting our food sources from these agricultural products, we can use those residues for the energy production. Now, forest residues, those include wood chips, sawdust, those account for 18% of the biomass energy consumption in India. These residues could generate up to 3000 megawatt of energy. Now, the municipal solid waste, another vital, that I already discussed, another vital biomass energy source, those contribute around 5% of total biomass energy uses. According to the Central Pollution Control Board, India produces almost 150 1500 or 15,000 tons of municipal solid waste daily, generating around 5,000 megawatt of power. Animal waste such as cow dung or poultry litter or produces, those are highly used for the biogas production. The Ministry of Renewable Energy, those estimates that India could generate up to 12,000 megawatt of energy from the animal waste. So India is also making huge contribution for the utilization of renewable energy using this biomass as a source. There are a lot of, as India is the larger producer for the agriculture, so there are a lot of agricultural residue that we can utilize in a fruitful manner for the generation of electricity or the generation of energy. Those are required, and also this kind of sources like municipal solid waste or animal waste, those are also used for the other valuable production like biogas generation and other energy generation purposes. So now I'll be discussing the role of bioenergy, that I already discussed that how it is taking important role. But coming to the economy and other product, let's discuss one by one. The share of the renewables in the energy matrix can be increased by including various bioenergy options. Now, the bioenergy initiative exists in several countries in the world that contribute a significant share of their energy matrix, providing the liquid biofuels, bioelectricity, biogas, and the heat. Sustainable biomass production can make a significant contribution to the climate change mitigation, also providing the diversification of the energy resources in a long term vision. Bioenergy has been under intense scrutiny over the last 10 years, with significant efforts has been taken in many countries to define bioenergy as a sustainable practice. Bioenergy, when it is coupled with the carbon capture and sequestration project, or the sequestration, carbon capture and the storage or sequestration concept, that will play a major role to mitigate the climate change. Bioenergy makes significant contribute to reducing carbon emission, especially difficult to decarbonize sectors like aviation, heavy transport, and manufacturing. In relation to fossil fuels, biofuels, which are commercially, we can say biofuels means ethanol. Ethanol as a biofuel that can lower human health toxicity and also reduce the greenhouse gas emission. In addition to that, biofuels can locally increase the evo, uh, evapotranspiration, which is nothing but when the water evaporates and passes through the atmosphere from the soil and vegetation, it carries out heat also from the land, which creates the local cooling. So, this land heating issue that also can be reduced by increasing the um, biomass biomass cultivation, right? So there will be biomass, biofuel also can be generated, and those are directly related. And with the improved soil carbon management and practice, those are also increase the soil carbon sequestration. Biofuels production that entails byproducts such as sugarcane provide not only water for the irrigation but also nutrients like potassium, saving the economic resources. Overall, bioenergy represents a relatively low cost and low emission source of the energy that does not face the challenge of intermittency associated with renewables like solar and wind energy. So, in that purpose, bioenergy would be the best biomass based energy. So, when considering the energy economy, um, this bioenergy accounts for also 9.5 percentage of total primary energy. So we can say that abundant and renewable bioenergy, those can contribute to more secure way, a secure future. By one, we can do that supplying the domestic use of clean energy, Also reducing the import of oil or other sources from abroad or foreign. Also generating, it will help to generate more job opportunities in a Indian, wherever it is in a local condition. And also revitalizing the rural economy, because mostly the bioenergy those are cultivated in a rural section, because we get lot of um, free land or the used land there in the rural area. So there will be lot of local um, job opportunities, as well as the economy, rural economy will be improved, right? Is there any question as of now? Any question? Um, Next, I will continue with the bioenergy that is in conjunction with the carbon capture and storage condition. So bioenergy, when it is as it is being like in a conjunction with the carbon capture and storage, it calls BECCS, which involves the capturing and permanently storing the CO2 from the processes where biomass is converted into fuels and directly burned to generate energy. Bioenergy can provide the high temperature heat and fuels that can work in existing engine also, and this technology, that bioenergy with CCS, plays an important role in decarbonizing the sectors which are in like such as heavy industry, aviation, and trucking, which and trucking in net zero emission by 2050 scenario. BECC relatively low cost compared to the technologies approved by the direct air capture. But according to IPCC, the land's scarcity, uncertainty about the availability of water and nutrient, potential social conflicts, and the lack of public acceptability will may have some constraint on the ability of BECCS, this bioenergy in conjunction with the CCS technology, to scale in a industrial scale, to grow up. There is a potentially there are some constraints because there have some land scarcity, also this kind of availability, uncertainty of the available water and other things, right? There are some constraints still persisting. to scale up this concept. Only around 2 metric ton of biogenic CO2 is currently captured per. Just this noise. Okay. Can you please, whoever it is, Manikandan, can you please post the question here? So, only around 2 metric ton of the biogenic CO2 is currently captured per year, mainly production for the bioethanol. Based on the projects currently in the earlier advanced stage of the development, capture on biogenic sources could reach around 60 metric ton of CO2 per year by 2030, which falls far short of approximately 185 megaton of CO2 per year captured from the biogenic sources by 2030 in the net zero scenario. So I will now discuss about the disadvantage when you are using the biomass energy source, because these are the challenges you will face when you are processing the biomass in the biorefinery or in a larger scale. So the biomass feedstock inherently deliver less energy per unit mass. That means less energy density than the fossil fuels. Also they contain more moisture, so this moisture removal we can, if it has the inherent moisture, then we cannot use directly for the electric heat generation, right? We need to remove the moisture content of the biomass so that we can increase the energy we can increase the energy density of the biomass feedstock. Also, there is significant energy which is consumed for biomass growing, harvesting, collecting, and processing. Processing that includes the drying to remove this inherent moisture from the biomass, also pelletizing and other things like transportation and feed stocking. So when it is we are talking about the biomass energy with the carbon capture and storage, so it imposes no additional energy demand on the processes relative to bioenergy without CCS. So when it is in conjunction with the carbon capture and carbon capture and storage, this bioenergy is conjunction with the CCS technology, it doesn't require that additional energy demand, because CCS itself, it is very energy intensive process. So so this bioenergy, when it is coupled with this CCS technology, it doesn't require the additional energy demand. So it is one of the plus point, but we have to encounter this, we have to tackle these challenges when we are addressing the biomass processing. So question 2 and question 10, those are same. I have to check the question. Okay. As per 2015, as per Energy Mix of India 2015, what is the contribution of renewable energy sources? So it might be uh, solar energy, but we have to check the data that what percentage it is contributing, because solar energy it is coming into picture before than biomass energy. Also in my wait also it is the case of world, considering the global CO2 emissions. So we can see the lot of CO2 emission is happening, including the solar. So as per my insight, it might be solar energy, solar PV. The percentage I'm not sure that at what percentage it is contributing. We have to check the data. So you can check the data with that IEA website. Um in that website, you search for 2015 data, and you can get the data. Hopefully. So coming to what we were discussing before, that is BECCUS or CCS technology. It can give you the heat production as well as electricity or power production, as well as we can get lot of biofuels when we are considering more focusing on the bioenergy part. So when the biomass is processed, that we know that CO2 from the exhaust emissions or from the process emissions, those are captured from the in the biomass, right? So these are biomass is, it is taking the CO2 from the environment, and environment, as well as we can say that from the exhaust emission and the process emissions, these are captured by the biomass, and then these are sequestered in the form of in the form of growing biomass, and the CO2 which are stored underground as a part of the CCS technology. And this is here So here we can use the biomass, and as a CCS technology, we are also capturing the CO2, storing the CO2. So out of this, we are also producing valuable chemicals, right? And heat source. These parts. So we are making an efficient way by combining the biomass energy source with the CCS existing technology. Now, for as an introductory part, this biorefinery and the other concepts are very detailed, and we will not discuss all the thing in this class. But as an introductory part, I will give a brief overview of the biorefinery existing, what are the technologies are existing, and biorefinery, what are the types of biorefinery. Those will be discussed in the future classes. So this biorefinery part will be the last discussion of our session today. So biorefinery concept, it came during the late of 1990s in parallel with the birth of green chemistry. The demand for biorefineries in the present context arises from three main factors: diminishing the petroleum resources, reducing the global climate change, as well as energy security. A biorefinery is an industrial facility that is capable of producing multiple fuel, especially chemicals and polymers from a wide variety of bioresources. This concept is very important in a context of circular economy, closing the loops of streams and valorizing the multiple outputs. Various kind of feedstocks from the household, agriculture and industry and the algae, those are can be processed through the biorefinery approach to produce the bioenergy and bioproducts. Different approaches are taken to classify the biorefineries. Those have emerged due to the wide variety of the feedstock, processes, and products that can be included. One of the most accepted forms, as it's classified based on the it is proposed by the IEA, based on our four main characteristics. Those are platform chemicals, what are the products, what are the feedstock, and what are the processes. Based upon these four factors, the biorefinery are classified into various categories. I'm not discussing details those categories now. We will discussing we will be discussing this when we will be discussing specifically a class dedicated to biorefinery portion. In a biorefinery platform, biomass is fractionated into a set of key intermediate chemicals of varying impurity. Those are further processed. It mainly works involving the thermochemical and the biochemical or enzymatic conversion processes producing a variety of solid, liquid, and gaseous fuels. Over the last decade, numerous demonstration plants have been commissioned, put into operation that have explored the conversion of cellulose into second generation processed foods to generate bioethanol and other compounds. So bioethanol, this is a uh, very useful product. That's why it is always mentioned at a specific way. But there are a lot of other bio-based chemicals. Those are valuable chemicals are being produced from the biomass resources. So when you can see that the rate of carbon capture is too slow in this process when we use the fossil fuel. So fossil fuel it itself took lot of time to generate. Millions of year time it took time this fossil oil to generate or formate. Now then we are utilizing it in the purpose of industry or other uses. We are emitting CO2. Now this CO2 how we are going to we are going to sequestrate and we are producing the valuable chemicals. This whole process is very slow. So when we are using the biomass, we can see that we are growing the biomass, it is taking CO2. And now when we are emitting CO2, it is again we are cultivating the biomass. So it is become a closed cycle. We are also producing valuable benefits out of that. We are also producing lot of chemicals. So when we are considering this figure is not visible properly anyways, so when we are seeing the biorefinery concept, so this is the sugarcane, this corn or wood, straw or other biomass resources, those are mainly harvesting. We use lot of energy for harvesting and processing. Then it is pre-processed. The first step is pre-processed and then it is taken to the industry where it is processing is there based upon the just like a fossil fuel oil, crude oil distillation. We also do the distillation of these products and we get biofuels, various chemicals and other things. And we can also recycle the used product and reuse it, right? So this is a very sustainable way and also a circular economy it represents. So the main technical challenges that we encounter, challenges of biorefinery. First one is we have to check the effective pre-treatment, and also we have to check what is the process efficiency improvement and what is the overall CO2 emission. I am writing down here CO2 emission in this case because we are maybe at some of the time we are utilizing the energy which is being produced by the fossil fuels. So we have to cross check this what will be the overall energy emission of the process. It should be net zero. So when we consider this effective pre-treatment process, there are a lot of cost those are associating in this process. It includes energy, huge energy consumption, huge quantity of different chemical and water consumption. This overall process should be optimized and improved. Also, the efficiency of this process and the biocatalysts which are used for the higher selectivity of the chemical production or the conversion of biomaterial into different products, those if efficient process should be chosen so that it results in lower cost and faster conversion method, right? So also better extraction strategies that represents higher product selectivity, those are very important to develop a efficient process. And this biomass feedstock, that transport should be minimized and storage should be efficient to minimum the feeds to minimum the energy requirement of the feedstock quality, to meet the feedstock quality. So those are some technical challenges, and that should be taken care in the refinery scale. Also, there are some also there is the implementation of the biorefinery. Those are mainly fueled by a few factors. Those important factors I would like to mention, that the energy supply, it should be sustainable. That is, we need to focus on renewable energy supply, and we need to reduce the import of crude oil. Also, inclusive of the economic growth, that will economic the overall economic the overall economic growth, that will support us, that we will not import so much, we will not rely on foreign crude oil or the foreign petroleum product. Also, maintaining the environment very friendly processes, like when we are using the catalyst, those kind of catalysts, those are not harmful for the environment. So those kind of in between process parameters we need to also verify to make the overall process very efficient, and in the um, vision of carbon footprint reduction. Also, not only carbon footprint reduction, but also we have to very careful about the economic environmental impact. We have to consider that. So this is a growing process in including the biorefinery coming to picture. This is a growing process, and uh, the lot of researches are going on in utilizing the biomass, but mostly the achieve means successful conversion and the utilization we have seen in the research level or in the laboratory level, but in the commercial level or in the industrial level, we need to do the more process optimization and more eliminating of the reliance of the fossil fuel consumption. We have to do those uh, detailed process optimization to make it effective for the biorefinery to take like in the commercial or in the full-fledged market application. So that's all for today's class. If any questions are there, I would like to take any question from the participants. Um, in the next class, we will discuss mostly on the energy crops and the mostly biomass based detailed lecture will be there on the next class. So if is there any question? Okay, so if there is no question, then I would like to end this session. Thank you all for joining. So we will meet in the next session. Thank you.